So, hello everyone. I am Eileen Romero. I am making this video in compliance for our subject Advanced Engineering Mathematics. So, in this video, I will be discussing about one topic which is the inverse Laplace transform. So, what is inverse Laplace transform? So, inverse Laplace transform is a mathematical operation that transforms a function of a complex variable f of s in the frequency domain back into a function of a real variable f of t in the time domain, where f of s is the Laplace transform of f of t. So, it was rooted in the work of Pierre-Simon Laplace and was further developed by mathematicians like Cauchy, Riemann, and Heaviside, ultimately becoming a crucial tool in engineering and physics. So, it's a crucial tool in solving differential equations and analyzing linear dynamical systems because it allows you to transform problems from the time domain to the frequency domain using the Laplace transform. Solve them in the frequency domain, and then use the inverse Laplace transform to get the solution back in the time domain. So basically, inverse Laplace transform reverses the Laplace transform and transforms from frequency to time domain. The inverse Laplace transform of a function f of s is denoted by this equation and is defined as this equation, where f of s is the Laplace transform of the function f of t. S is the complex frequency variable, sigma is the real part of s, and t is the time. So basically, the inverse Laplace transform is the reverse process of Laplace transform. For example, this one, 1 over s, the inverse Laplace of 1 over s is equals to 1. So the inverse Laplace of f of s is f of t. So the relationship between Laplace transform and inverse Laplace transform is that if f of s is the Laplace transform of f of t, then f of t is the inverse Laplace transform of f of s. So in conclusion, the inverse Laplace transform is a powerful mathematical tool that allows us to convert functions from the Laplace domain or the frequency back to the time domain, enabling the analysis and solution of various problems in engineering, physics, and mathematics. So to understand more about inverse Laplace transform, let's dive into some examples. Example number 1. So, example number 1 is to find the inverse Laplace of 5 over s plus 2. So, the Laplace transform of e raised to at is equals to 1 over s minus a. So, the inverse Laplace of 1 over s minus a is basically e raised to at. So here, 5, the inverse Laplace of 1 over s minus negative 2 since a here is negative. So now 5. Then the inverse Laplace of 1 over s minus negative 2, where negative 2 is the a. So the final answer would be 5e raised to negative 2t. So this is our final answer. Example number 2. So the inverse Laplace of 6 over s minus 1 over s minus 8 plus 4 over s minus 3. So now we can distribute the inverse Laplace. So inverse Laplace of 6 over s minus the inverse Laplace of 1 over s minus 8 and plus the inverse Laplace of 4 over 5, s minus 3. So now we can have the 6 inverse Laplace of 1 over s minus inverse Laplace of 1 over s minus 8 plus 4 inverse Laplace of 1 over s minus 3. So we don't have a problem on this since the inverse Laplace of 1 over s is simply 1. So 6 times 1 minus 1 over s minus 8. So we can recall that the inverse Laplace of e raised to 80 is equals to 1 over s minus a, wherein our a here is 8. So this inverse Laplace will be equivalent to e raised to 8t plus 4 and the inverse Laplace of 1 over s minus 3, which is e raised to 3t. So our final answer would be 6 minus e raised to 8t plus 4 e raised to 3t. Example number 3. So the next one is inverse Laplace of 10 over s plus 2 minus 1 over 3s minus 5 plus 7 over s raised to 5. So now 10 inverse Laplace of 1 over s plus 2. So we already know that this is already, we all know the inverse Laplace of this one, which is e raised to 2t. But we will write this one as 1 over s plus 2. Let's focus on this second one. So what we will do here is to factor out 3. So it becomes 1 over 3 times s minus 5 over 3. So this is still the same if we multiply 3 by s minus 5. Plus 7 inverse Laplace of 1 over s raised to 5. Then 10 e raised to 2t, negative 2t, since this is positive here. So as we can recall, if 1 over s minus a, it will become e raised to at. So if this one will become positive, 1 over s plus a, it will become e raised to negative at. So minus 1/3 inverse Laplace of 1 over s minus 5 over 3 plus 7. So since this is 5, 7 times 4 factorial over 4 factorial. So in order for this inverse Laplace to become 4 factorial, so that it is readily available for transportation. So the final answer would be 10 e raised to negative 2t minus 1/3 e raised to 5 over 530 plus 7 over 24, since 4 factorial is 24, t raised to 4. So this is our final answer. That's all for my video. Thank you for watching.